weather radar network that the National Weather Service runs. We get into some scanning strategies and how it works, and a brief overview on Radar 101, and we get into topics of Doppler velocity, correlation coefficient, the future of weather radar, and finally, some pretty picture time. So, starting off, this is our basic WSR-88D, and these are the radars that the National Weather Service uses on the daily basis. And again, the 88D in there tells you that these radars are all developed and made back in 1988. So they're approaching now 40 years old-ish, and maybe they'll be replaced soon, who knows. But we're still stuck with 1988 technology for weather radar. We have had advances in the data processing back in throughout the years that allows us to better interrogate storms and the storm structure. So there are about 122-ish NWS weather forecast offices around the country, and each one of these offices runs and controls their own weather radar. For example, for our local weather forecast office, the weather radar is located at the Preston Smith Airport. Probably seen that big white ball over there ever flown out of the airport up there. And there are about 122 of those all across the country. We're looking at the coverage maps that each of the radars can cover. So every location there in the, say, the tannish, light yellow color up on the map has good radar coverage. All the black dots represent where all the radars are, and all the white spaces on there are the areas of no radar coverage, and the blue is poor radar coverage. And we do see a lot of space in the western half of the US that has very poor, if any, radar coverage. And while it's not great, I'll say, luckily the eastern half of the US has a lot more coverage, as most of the severe weather in terms of tornadoes, hail, and strong winds occurs in the eastern half of the United States, east of the Rockies. And so how weather radars work exactly, I'm going to pull up a brief video here in their pattern. I'll loop this a couple times. Essentially, they start and scan in the circular pattern all the way around at a low degree or scan angle. And they scan all the way around to a full loop, then they go up a degree or two, do another full loop, and they continue that pattern all the way up to about, I think it's 20 to 30 degrees-ish, and it finally ends off for the full radar scan. And this allows you to get a full 3D structure of the storm, which is very useful when it comes to warning severe weather. And yeah, it gives you a nice 3D structure. But the problem with this is, if you have a severe weather event, say a tornadic storm,